to border, coast to coast. It's time to cue the talent and meet our host. It's a podcast by George. All right, folks, it's showtime.
Hello, hi, how are you? Welcome on in to another podcast by George. Well, frequent viewers, people that watch my show know the big three on podcast by George: climate, war, and healthcare. And I kind of rank them in that order because, you know, war is going to kill a bunch of people. Hell, it may kill us all eventually, but I got a feeling climate might be the biggest threat, and all the pollutants and everything associated with that. That's why it's at the top of the list. And of course, healthcare is in there as well. And this article today that I saw in Capital Dispatch dovetails very nicely with the theme of the podcast and our guest today. I want to give a little bio here, a little read of what he's all about. It's Dana Kolpin. He's a research hydrologist with the Central Midwest Water Science Center. Now, I'll give the long-form bio here. Next time we have him on, we'll shorten this up a little bit, but I want you to know all about him. He received his BS from Iowa State University and his MS from the University of Iowa, both in geology. Now, Dana started his career with USGS in 1986. His research interests include the effects of environmental contaminants like pesticides, human and veterinary pharmaceuticals, hormones, etc., in the environment. He was the project lead of the USGS Toxic Program CECs in the Environment Project for its entire history, 1998 to 2017. He now is the project lead of the USGS Toxic Program's newly formed Food Project, and that's understanding the potential for health risks from contaminant exposures associated with production, manufacturing, use, and consumption of food, beverage, and feedstock products. He has published over 200 papers and reports on environmental contaminants. So let's welcome him on in. Dana, welcome to a podcast by George.
Thank you, George.
You know, the way that I describe my concern about the climate and the water quality issues, and it's kind of like my own experience with DIY projects, or maybe even going, you know, back to my childhood. We used to have a saying, "Don't hurt yourself." But if I'm doing a project myself, I'm not very handy, Dana. So my first mission is don't screw something up that can't be undone. I mean, and I play hockey, and I love to play hockey, but when I go on the ice, it's always, you know, don't hurt yourself so that you can't heal. I mean, don't hurt yourself so that you can't, live to play another day. Well, this article that I saw, and I'm going to bring this up on screen, really struck me right along those lines. This is from Iowa Capital Dispatch. A new study finds forever chemicals in streams across Iowa. A first-of-its-kind study of rural Iowa creeks and rivers found traces of synthetic chemicals that are toxic and persist in the environment indefinitely at sites across the state. They're all over the place, said Dana Kolpin, our guest today. He's with the USGS, as I mentioned. He led the study. The results were published this month. They found evidence of, and I'm not even going to try to pronounce these, Dana, PFAS. So let's start here, these forever chemicals. What are we talking about here? What's a forever chemical?
Yeah, these are sets of chemicals that have a lot of versatile properties that make them really beneficial for a whole range of products. It can be things like your Teflon coated cookware. That's probably where most people are familiar with that. But they also are used in pizza boxes, so it keeps from your cheese from sticking to the top of the pizza boxes. So it's their non-stick properties. They have heat resistance. So they have a lot of beneficial properties that make them attractive for use. And they have extremely strong carbon fluoride bonds. But unfortunately, it's those same properties that makes them versatile for everyday use, makes them persistent, mobile, and bioaccumulative. And so that's where now that we've used them for so long, and now we're finding that, in fact, they're actually all over the place in terms of in the environment. They're in our surface water, they're in our groundwater, we find them in the air. So that's kind of a double-edged sword where they have a lot of beneficial uses and they've really become ingrained in today's society, but now we're finding that could be coming at a price.
Yeah, you mentioned Teflon, and I'm sure you've heard this before, and I'm sure you're aware of it. If people say, those Teflon pans that we used to have as kids, I mean, that stuff, that coating came off, and it was in the pan that we were cooking, and it probably went in us. Some people would say, Dana, that these things don't harm us, that these chemicals are beneficial, and they're not detrimental, but I'm assuming you're going to disagree with that.
Yeah, I mean, I'm not a toxicologist, but what I've read is the mounting evidence that there is environmental effects and human effects, whether that's affecting our thyroid function, cancer, a whole range of things where we're just beginning to understand that they are having effects. I think there's a lot yet to be learned, so we don't know all the consequences, but there's enough mounting evidence that suggests we really should be thinking about these and be concerned about their entry into the environment.
Well, we're having unique weather. I started off talking about the climate. Unique weather is probably the nicest way to put it. I mean, we have these calamitous weather catastrophes that I believe are associated with the climate catastrophe that we're experiencing, and they seem to come regularly. And we're going through one in the form of a drought. Farmers are applying nitrogens at the northern part of the state. I just had Cal Sorensen on. He farms up north of Humboldt, I believe, up in the northwestern part of Iowa. The rivers come to this part of the state. Well, they didn't have much rain this year. They didn't have hardly any runoff. Good news, bad news. That means not much nitrogen ran off this year into the streams. There's hardly any water in the streams. That's the really bad news, I guess. But the other bad news, I would think, is that nitrogen, I mean, it ain't going anywhere. It's there. It's ready to be released. And if we have what we seem to have, drought broken by violent storms like a derecho or some damn thing like that, that nitrogen, those forever chemicals that you're talking about, they're kind of like a ticking time bomb up there.
Yeah, that could be. I mean, but we don't understand the transport mechanisms for PFAS as well as we do for like nitrate and pesticides. And you're exactly right. For those kind of better understood agricultural contaminants, they're used, there's no rain, so they're sitting there in the soil, kind of just ready to be transported. And then you get the big rain and it get the pulse to the streams. Are we having the same kind of pulses with these forever compounds? We don't know yet. The hypothesis is, there could be, but that's the kind of research we need to understand. Is the study that I did provide some baseline information that just wasn't there before. People hadn't been looking at these rural small streams that as you're driving across Iowa, you drive across a little creek and you don't think much about it. And those are the stream settings that most people hadn't looked at until this study. So we really don't know a drought condition where farmers are applying manure or there's biosolids being applied to the field, and then you get a big rain. Is that driving contaminant transport to streams? That's a likely scenario, but that's something we got to test yet and really understand.
I heard you say biosolids. Is that what folks like me would call pig manure or worse? Is that what we're talking?
That's on the municipal side of things. So that's kind of through a wastewater treatment plant that accepting human waste. Through the treatment process, things settle out and they separate the liquid from the solids. And again, the solids is the nice term. And the liquid then gets discharged into various creeks. And that leftover material, the sludge and biosolids, it's treated for pathogens and it's treated for what the EPA requires. But all these other compounds are not treated. So it's concentrated in the sludge, and I call them the biosolids. And then at least half the biosolids in the U.S. are land applied, including here in Iowa. And that's used certainly for a beneficial reuse of nutrients and organic matter for the soil. But there could be all these other Trojan horse type contaminants are in that stuff. So I consider the biosolids the human side of things, and then the livestock manure is kind of what you're referring to with all the, we have way more livestock in the state than we do people. And that's what we really need to understand. We know the biosolids contain PFAS and forever compounds. There's just starting to be research to get an understanding that there also could be these same compounds in the livestock waste, probably at lower concentrations because cattle aren't cooking with Teflon or whatever. But there still could be other pathways or other uses that get them in there as well. So that's what we need to understand. This baseline study we found a third of the streams across Iowa that we measured had PFAS in it. But a lot of the streams we only sampled once. So again, it's enough of a baseline to say, oh, this is something we need to look at further and just investigate to see how prevalent these are in other times of the year, because a one-time sampling of a stream is not going to tell you what's there over the course of a year.
Let me bring up this article again. I wanted to have you comment on one part of it that I wasn't real clear on. Now, it's an excellent article in Iowa Capital Dispatch. The author is Jared Strong. It's this map here that we're showing, the number of PFAS detections and the coloration on this map. What are we seeing here, Dana?
Yep. So basically, it shows the basins that we sampled across Iowa, and the sites in gray are the areas where we didn't have any samples. So it really shows about 90% of the basin area in Iowa was captured by this network of 60 streams we looked at. The sites are in yellow, or the basins where we found at least one PFAS in at least one of the samples. This was kind of a spatio-temporal sampling. So some sites were only sampled once, but others we sampled 4 to 6 times. So it shows where we found PFAS in the basins in white are where we collected samples, but at least with this sampling effort that we didn't see any PFAS. Doesn't mean they may not be out there, because again, we weren't optimized to capture the maximum concentrations. This was kind of, we just went out there when we have to have people in the field, but this was a starting point to give us baseline information for the state that we didn't have before.
And you just touched on something I wanted to ask you about, because you mentioned when you happen to have people out there. This sounds almost like a volunteer effort, that you were doing this when you had a chance to do it, when you were there for other reasons. Is that the case?
Exactly. Well, I call it kind of convenience sampling. Once we had the method available, and that was kind of the middle of what I call our fiscal year, our funding was already kind of booked, so to speak. So what we were already going to streams across Iowa, looking at antibiotic resistance and so forth. And the USGS is always having people in the field to look at water quantity. You may have seen our USGS gauging stations for flooding purposes. So what we decided to do is getting people in the field is one of the costly components. And if we already have people in the field for other purposes, the sample collection for PFAS for this method is just a little tiny 2 milliliter tube. So it's very, very simple. So I was able, and Shannon Meppelink and others on our team said, when you're in the field, can you just collect these little tubes for us, put them in a cooler, bring them back to us, and then we'll see at the end of the 6-month period, what do we have for a spatial temporal sampling? And that's where the Center for Health Effects and Environmental Contamination at the University of Iowa joined us and said, and I went to them and said, we have all these samples. I don't have a mechanism for funding at the moment. And they say, fantastic, we will fund you to analyze these samples. And that's how we got this paper. Really, for a shoestring budget, again, like you said, it's kind of just piggybacking onto ongoing efforts. And that was a way for us to kind of get this whole thing jump-started.
Well, let's expand that budget. Jeez, I mean, this is really critical. I'll tell you the one part of this that just leaped off the page to me, Dana, is this part about the food chain, because we don't think of it in that context a lot of times, but we should. These forever chemicals are moving, they're migrating through the food chain. Talk about that a little bit.
Yeah, absolutely. And that's what I see is the big thing that kind of raises my eyebrows as well. I've been looking at contaminants for decades, and there's certain things, let's say nitrate, for example. Everybody's kind of familiar with nitrate in high concentrations above 10 milligrams per liter. There's blue baby syndrome and things. There's real concerns about that. But if nitrate, you can find nitrate at 0.001 milligrams per liter. And for nitrate, if it's that super low, you could probably say, yeah, it's there, but no big deal. But for these PFAS compounds, no matter how low we're able to measure, they still are important because they bioaccumulate. So a trace level exposure now builds in your body, you get another trace level, and eventually it can build to the point that it may have an impact, whether that's this year, whether it's 5 years from now, whether it's 20 years from now. So that history of exposures makes a difference. And so others have shown there's definitely a food web component. So when you find traces in the water, and that's one thing I want to stress for this study, we only looked at water. That's what we had available at the time. Others have shown that water really underestimates environmental exposures because these compounds also like to stick to the bed sediment, the kind of the muck and sand on the bottom of the stream bed. And there's a lot of organisms that like to hang out, mess around and live in those. So it's not just the water exposure, it's their exposures via the sediment it builds up into their tissue, whether it's an aquatic bug, for example, let's say a mayfly. Part of its history lives in the water. And then the next part of its life stage, it emerges from the water. And then a tree swallow will eat that bug. And so then it gets from the water and sediment into the insects, and then other organisms eat it, whether it's a fish or a bird, and it just keeps building through the food chain. And we are a part of that food chain as well.
Well, let's talk about fish. I mean, that's a part of the food chain that I understand. I know people that won't eat fish out of rivers and streams in Iowa any longer. Are you finding evidence that they probably shouldn't?
I don't know if they shouldn't. That's a question I can't really answer, but I can say that early evidence suggests that these compounds probably are in the fish tissue, but we don't know what that means yet. So I think the big thing is we need to understand what's there, and then let the toxicologists and others then determine, is that something that we should or shouldn't be doing? But I can't address that question.
As you mentioned, you've been studying a long time. You've been looking at this. You've been looking at water quality issues for a long time. You mentioned your eyebrows raised on this food chain issue. When you saw these latest results, the samples that you got, I mean, did your eyebrows simply raised, or was this a slap your mama moment? I mean, is this something that really startled you?
No, because I think we're kind of expecting that. I mean, the research is showing these are forever compounds. So there's no reason to say that once we started looking for them in our state, and we just didn't have as much information in our state as say other states did. So it's not surprising that we found them. I mean, the good news is, even with this effort, we only found them in about a third of the stream. So, but again, that's a one-time sampling. So I think if we start adding the bed sediment, we start adding tissues, for example, water, maybe there's a flush and it's only measured in the stream in a short window, but a fish lives in that stream its entire life cycle. So that's another important reason to collect fish and other organisms, because a one-time or just a periodic sampling of water in particular, we just may not be able to adequately represent kind of exposure concentration. So again, was I surprised? No, I think it kind of confirmed what our hypothesis was. But we just need to, again, we kind of just need to figure out a better understanding of how prevalent these are, because this was just a taste of what just kind of gets our understanding started of what's out there. And we just need more. I mean, that's kind of the researcher response to me. We always need, as a scientist, you always want more data to get, to kind of confirm and solidify what's going on out there.
Well, it creeped me out. Like I said, forever chemicals, forever poisons, these things that can't be undone. I talk about the climate on the podcast, and that's my primary concern. Not only are we way behind, but we're suffering consequences that can't be unwound. It's going to get worse, but it's never going to get back to the way that it was. And that is the case here if these things are indeed forever. Let's hope that they can be flushed out of the water, but as you mentioned, they didn't come out of the fish or the animals that have an entire life cycle because of that. Well, I want to thank you for coming on the podcast on such short notice. That always tells me that somebody knows what they're talking about, and somebody that's honest, because they don't need a lot of preparation. Dana agreed to come on the podcast within about a half an hour of my contacting him, and maybe it's because this is such a serious issue. And before we leave here, give you a last word to summarize this and that article that I had up and your reporting in the paper on this. How would you kind of encapsulate it for folks?
I would just say it's an educational opportunity to understand that these compounds are in our water resources here in Iowa. So we just need more information to understand what that means. I mean, I don't want to say the sky is falling and we need to stop using these compounds. They had a lot of beneficial uses, but we just need to understand, can we be using other compounds that maybe aren't as forever, so to speak? Do we need to have these in our dental floss and all these other kind of compounds? Can we be using something else that may be safer? So I think stay tuned is maybe the way to go about this, and think about what we're using, because that's, with my long history of research, really become to understand that everything we use has a potential to be an environmental contaminant. So we're a very chemical dependent society, and we need to start thinking about, making sure that what we're using doesn't have any consequences that we may regret later.
Ah, well put. Don't do something just because you can. And that dovetails again with this farming stuff that I've had on lately. You have to think about the long-term harm that can be caused. The Teflon thing's a perfect example. We can get along without Teflon coatings on our pans. My mother and grandmother got along just fine without Teflon and on pans and cookware and that type of thing. My God, I hate to think that I might be carrying some of that around because, as I mentioned, it's anecdotal, but I never forget those scratched off Teflon pans. Well, that's going to do it for this particular episode. Again, thanks for coming on, folks. We've been talking to Dana Kolpin. He's a research hydrologist for Central Midwest Water Science Center. Dana, thanks for coming on this edition of Podcast by George.
Thanks for having me.
Folks, I hope you enjoy these types of interviews, and if you do, please go to podcastbygeorge.com and sign up. Pick an icon. It's all free. You can subscribe on YouTube, or you can follow us on Facebook. You can also get us on iTunes, the iHeartRadio app, Spotify, all places where podcasts are seen or heard. But that's going to do it. That is going to wrap it up. That's all there is, and there ain't no more. That's another podcast by George.